In today's video, I am going to focus on how to divide using long division when we have a double-digit divisor. Now, remember, our divisor is the number that we are dividing by, so it's the number outside of our division bracket, and double digits just means that we have two digits here. Okay, before we would only have a single digit. Now we're going to have double. And I'm going to start off by focusing on double-digit divisors that are multiples of 10. They're a little bit easier to work with, and then we are going to branch into double-digit divisors that are not multiples of 10, such as 23 over here. So we're going to be starting off with 20 divided into 480, or 480 divided by 20. When we have a double-digit divisor that is a multiple of 10, we can check to see if our dividend is also a multiple of 10. Basically, if it ends in a 0, it's a multiple of 10. And if it is, we can make the problem easier on ourselves. For every 0 we have over here, we can take off a 0 over here. So if I take off this 0, I can take off that 0. So now, instead of dividing 480 by 20, I'm actually going to be solving 48 divided by 2. Because we got rid of this 0 by getting rid of that 0, and vice versa. And all we're left with is 48 divided by 2. Well, that's a simple problem. Our answer is actually still going to be the same. 2 goes into 4 twice. That's 4. We subtract and we get 0. Bring down our 8. 2 goes into 8 4 times. We get 8. Subtract and we get 0. So our answer here is 24. That's our quotient. Now, in case you're wondering, well, that's what 2 times 24 gets us to 48, but we started off with 20 divided into 480. Well, let's check by going 24 times 20. Well, our first partial product is just going to be 0. 0 times 4 is 0. 0 times 2 is 0. Now, put in our 0 because we're moving over to the tens place. 2 times 4 is 8. 2 times 2 is 4. And when we add them together, we still get that dividend that we wanted to have. 480 matches. So it doesn't matter that we took off those zeros. So that's one shortcut that we can use. Let's try a different one using this little shortcut. Here we've got 52,000 divided by 400. Well, since I have 2 zeros over here, I can get rid of 2 zeros over there. So we're actually going to end up with 520 divided by 4. Once again, just so happens we have a single-digit divisor now, which makes it a little bit simpler. So 4 goes into 5 once. We get 4 and subtract. Bring down our 2. 4 goes into 12 3 times. We get 12, subtract, and we get 0. Bring down our other 0. Now, some of you might think that our answer is 13. But it won't be because we brought down another digit. We had a digit to bring down. So now we got to ask how many times does 4 go into 0? And it doesn't. It doesn't go into 0 at all. So it goes into 0 0 times. So our answer, well, hold on, 4 times 0 is 0. Subtract and we get 0. So 4 divided into 520 ends up being 130. And if I use my multiplication, 130 times, well, let's use the original number, 400. 400. First partial product is just going to be 0. Put in our 0. Second partial product is just going to be 0. Now, since we're moving over to the hundreds, we put in 2 zeros. Then 4 times 0 is 0, 4 times 3 is 2, or 12, carry the 1, and then we've got a 5. So it ends up being 52,000 still. Now you might be wondering, what are we going to do if we can't do this 0 trick? Because the zeros make it a lot easier, but we won't always have zeros. So let's try an example now where we don't have any zeros in the problem. This time we're dividing 675 by 15. And as you're noticing, like I said, we don't have any zeros. And you might think, oh, this has a 5 and that has a 5. Can't do that little trick where we get rid of things. Doesn't work unless you have zeros. Sorry. So if we're going to divide 675 by 15, one of the best ways we can handle double-digit divisors is to make a quick list of some of the multiples of our divisor. Off to the side, I like to go 15 times 1 equals 15, 15 times 2 equals 30, and I do that for a couple multiples just so I have something to base it off of, because more than likely if we're using double digits in our divisor, we're going to be using numbers that we don't know for our basic facts. So if we can have a little list to help us, it makes it that much easier. This is a 60, and then let's end at 15 times 5, which is 75. So now that we have our list over here, we can think to ourselves, just like before, can 15 divide into 6? No. So we're going to put our 0 up top. Now we've got 67 to work with. Can 15 divide into 67? Well, take a look at our list over here. What's the closest we can get to 67 without going over? And hopefully you realize, oh, it's 60. So 15 times 4, 4 goes up top, and the 60 goes underneath. Subtract, we get a 7, and we bring down our 5. The process for double-digit divisors is the exact same process when we had single digits. We just might have some bigger numbers to work with, and that's okay. We shouldn't be scared of bigger numbers. Just think of them as a challenge that we can overcome. So now we're dealing with 75. How many times can 15 divide into 75? Well, look at our list. And we've got down here, 15 times 5 is 75. So 15 goes into 75 5 times. 15 times 5 is 75. We subtract and we get 0. Just so happens we don't have a remainder, so our quotient is 45. And, like always, we should check our answer. So what's 45 times 15? 5 times 5 is 25. Carry the 2. 5 times 4 is 20, plus 2 is 22, so our first partial product is 225. Put in our 0 because we're moving over to the tens place. 1 times 5 is 5. 1 times 4 is 4, and if we add all those up, we get our dividend of 675. So we've done it correctly. Now let's try another one. For our last example here, we're going to try to divide 11,746 by 23. It's the biggest number we've worked with so far. We've got a decent sized divisor here of 23. So just like before, as I said, off to the side, make a list of your multiples of 23 that you can. I always like to try to go the first 5. So 23 times 1, 23 times 2, 23 times 3, 23 times 4, and 23 times 5. So 23 times 1 is 23. If we add 23 to that, we get 46, which is 23 times 2. If we add 23 again, we get 69, which is 23 times 3. Then we get 92 by adding 23 again. And lastly, we get 115. Now that we have our list, let's do some division. Start off just like we always do. Can 23 go into 1? No. So we put a 0 up top. Now we work with 11. Can 23 go into 11? Now this is the first time where we have to say no. 23 can't go into 11, so I have to put a second 0 up top. And now we actually use the first 3 digits, and we're dealing with 117 now. Couldn't use the 1, couldn't use 11, we have to use 117. So, look at our list over here. What's the closest we get to 117 without going over? It's going to be 23 times 5, which is 115. So, 23 goes into 117 5 times, which is 115. Now we subtract like normal. Well, 117 minus 115 is just 2. we'll bring down our 4. Repeat our same process. Nothing has changed from our normal division. Now we've got 24. How many times can 23 go into 24? Looking at our list over here, it looks like only once. So 23 goes into 24 one time. We subtract 23 from 24 and we get 1. Bring down our 6. So now we've got 16 down here. And if we look at our list, well, 23 is the smallest we get. And that's still too big for 16. So 23 can't go into 16, so we're going to have a 0 up top. 23 times 0 is 0. Subtract and we get 16. So our answer actually ends up being 510, remainder 16. That remainder might look a little big. We don't normally have remainders as big as 16. But as long as the remainder is smaller than the divisor, there's a good chance we've done it correctly. If it's bigger than the divisor, that means we could have gone into something that we didn't. So let's check our answer. I'm going to erase my multiples over here. We have 23 times 510. So 510 times 23. 3 times 0 is 0, 3 times 1 is 3, 3 times 5 is 15, so our first partial product is 1,530. Now we've got put in our 0 for moving over to the tens place. 2 times 0 is 0, 2 times 1 is 2, and 2 times 5 is 10. So our second partial product ends up being 10,200. Add them together, 0, 3, 7, 1, 1. We get 11,730. We have 11,730, but we wanted 11,746. Don't forget about the remainder. When we have a remainder, we have to add that back in after we do our multiplication when we're checking. So if we add 16, 6 plus 0 is 6, 3 plus 1 is 4, everything else stays the same. And there we have it, 11,746. So that's how we divide with double-digit divisors. Sometimes we might have multiples of 10, and we can cross off zeros at the end if we have those. Otherwise, making those lists of multiples like we did in the past two problems can be very beneficial to making dividing with double-digit divisors a lot easier than it looks. Hope you enjoyed this video.